Hey everyone. So today we'll be looking at 54, that is a spiral matrix problem from Leetcode. So without further ado, let's get started. Let's start the timer. So we have been given an m into n matrix, written all elements of the matrix in spiral order. Gotcha. Mm-mm. So we are starting from 1, 2, 3, 6, 9, 8, and we have to travel inside. And similarly here, 1, 2, 3. Okay, so I suppose we need to keep track of the top, left, bottom, right, like that is what our area is, right? So we want to make sure that we are traveling inside until what? Um, so let's so yeah, I straight away jumped onto the question. So let me ask few questions regarding this. Like I hear that we have m into n matrix. What size of the matrix would be it? So okay, m will be greater than equal to 1 and n is, so it will be um between 1 and 10. N, m and n would be between 1 and 10. Okay, got it. Okay, so I just want to create an array first of all, whose value would be whose size would be m into n, right? So that's one thing. We want to return a array of size m into n. That's there because we'll be anyways traversing the array. So let me think about it, how I can proceed with this problem on my notepad, and then I can, you know, start solving this problem and explain you what my thought process is. So I'm just wondering how I can, traverse this array, this 2D matrix. So obviously I have to start at 0, 0. Um, so let's look at the smaller um, matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 0, 1, 2, 0, 1, 2. Okay, got it. So till what point I have to do this? I need to make sure that I'm following the right intuition behind this. So let's say we have top, bottom. So I'm trying. I guess at this point I'm trying to remember how I already solved how I earlier solved this problem. Um, let's say you have to solve it, and then what I need to do is travel with the, so I need a counter where it will be I need to access the matrix. So I have to traverse this, then this, then this, then this. Okay, how will I set the boundaries? I'm thinking, how will I set the boundaries? Is there a hint for this question? Yeah, there is a hint. Well, for some problem, the best way really is to come up with some algorithm for simulation. Basically, you need to simulate what the problem asks you to do. We go boundary by boundary and move inwards. This is essentially essential operation. First row, last column. First row, last column, last row, first column, then move inwards. So how will I okay, so I basically get the idea of it. I was thinking the same thing. But until what point we have to do this, that's the concern. So they are seeing first row, then last column, then last row, first column, then move inwards, move inwards. Okay, so let's determine what is our row's length. So row length is here 3, right? 3, and column length is also 3. mm, I need to go from this point, 1 to this is a tricky question. So my boundary, um, so my end goal is to reach 5, right? The middle portion of this. But when it's a weird numbered array, then how can we find the center, like where we'll be ending up? This I'm going nowhere with this problem. Let's see the editorial, what the editorial is saying. The problem statement asks us to return all elements of the matrix in spiral order, which means we will start from the top left corner and move to the right, towards right, then down, then left, and then up. Let's break this into further details. We can achieve moving in different direction by modifying row and column indices specifically. We have given that we are at row and column, where row is the row index and column is the column index. Row, column plus 1, row plus 1. Yeah, I know that. But till what point we have to do this? When shall we change our direction? We need to turn when we either reach the matrix boundaries, or we reach the cell in the array that we have visited before. Matrix boundaries are fixed and provided already, but now could we know if we have visited a particular cell or not? In fact, we have two different strategies. They will be introduced in the following approaches. Generally speaking, they are as follows. We can move the boundaries towards the center of the matrix after we have traversed a row or a column. Then we meet a boundary. We know it's time to change the direction and update the boundaries. While traversing the matrix, we can record each location that we have visited. Then, when we meet a matrix boundary or a previously visited cell, we know it's time to change the direction. This is a good time to stop and see if you can come up with the implementation yourself. I guess I'll keep on reading. Okay. So our goal is to update boundaries as follows. When we finish traversing a row and a column, we want to set up a boundary on it so that next time we get there, we know we need to change the direction. Here is demo for the first round of updating the top right, bottom left boundaries. Okay. Initialize the top right, bottom left boundaries as up, right, down, left. Initialize the output array result. Traverse the element in spiral order and each element to result and add each element to result. Traverse from left boundary to right boundary, up to down. Before we traverse from right to left, we need to make sure that we are not on a row that has been already traversed. If we are not, then we can traverse from left to right. Similarly, before we traverse from top to bottom, we need to make sure that we are not on a column that has been already traversed. Then we can traverse. Okay, so we take this. Top up is left is 0, right is, so yeah, this was the thing. Result dot size is less than rows into columns. Yeah, okay, yeah, that was the basic thing, right? We needed to add all the until we reach this thing. So int column is equal to left, column is equal to less than equal to right, and then we have to add this up, then row plus 1. Okay, so row right, and then make sure we are on a different row. Up is not equal to down. Traverse from right to left. Make sure we are now on a different row now. Sorry, make sure we are now on a different row. Yeah, right -1. Okay, we have to go this way, then make sure on different column right and left are not overlapping each other. Okay, so before I jump onto the question, I really want to understand what's going on. So let's open Miro board. Okay, so we have this guy, and let's draw the 1 2 3 4 5 6 7 8 9. We have 0 1 2 0 1 2. We have to move this way, so let's not draw anything for now. Okay, so once we have this, we know that our row is equal to what do you say, row is equal to 3 and column is equal to 3 here. So we need to move from top is equal to 0, and our left is also equal to 0. Our right will be pointing to column -1, and our bottom should be pointing at row -1. Okay, so that's right. And then what we do is we start while we do our result is not filled up with all the elements. Its result array is less than row into column length. Then we'll keep doing this. That's what I was missing. That's what I should have thought about that. But yeah, no worries. We'll get better next time we come across such question. So yeah, what we need to do is we need to check, first of all, loop this guy, right? This guy we have to loop. So our columns would be changing. So for column 0, or should we say left, Yeah, it should be left. It should be definitely called left. Left, and column is less than equal to right, and then call plus plus, and what we need to do is um, result dot push. We need to push this. um, can I just move this guy here and reduce the size okay, let's keep it right here. Okay, so and push row would be same, row won't be changing, that is top, and left, sorry, column, and we'll simply push in result. Let's do result here. After performing this, we'll be adding 1 2 and 3. So once this is done, we need to traverse this section. So we need another for loop in which we have to traverse the rows. So right is pointing to the column minus 1, right? So we need to make it shift a bit down. So row right, we need so yeah, I'm thinking what we need to do here. So in the previous step we already visited this guy, right? So 3 would be the, we don't want to iterate 3 again, like this is common. um, if I do column plus 1, then okay, let me think, am I doing this right? Or oh, no, so we have to do top plus 1, because anyways we'll be shifting to the next row, right? So top plus 1, I hope I'm doing this right. Top plus 1 and row is less than equal to bottom, right? So bottom, and then we do row plus plus. So result dot push, what will push is row would be changing, and the and right. So row and right. Okay, once you have done this, then you are at the bottom, and you need to make sure that your top doesn't coincide with the bottom. So here we are checking if top is not equal to bottom, and basically we run the for loop for the columns which would in the reverse order, right? Which would basically start from right minus 1, because we want to shift this side to the left hand side, and then call is greater than equal to left, and call plus plus, because we want to make sure that we don't uh, go to the go to the positions that we have already visited. And oh, I am sorry, you guys are not able to see this. And then we will keep our bottom as is, and we will shift our column. So at this stage, sorry, I forgot to update 1 2 3. We got 6 9, and then we got 8 7. And should I zoom out a bit? Yeah. So but this won't be too visible, right? Yeah, okay. Anyways, then in the end, what we gotta do is, if left is not equal to right, then for row we want to again go up, right? So what we'll do is bottom minus 1, we need to go bottom minus 1, and then call sorry, row is greater than equal to top, because we don't want to not equal to, actually we don't want to make it equal, less than. Here we have to do minus minus, not plus plus. And row minus minus. Okay, and here we will add left. So we are traversing row by row, right? So row will change and left would remain same. Yeah, once we are done traversing, then we'll be needing to update. So top will be decremented, left would be, sorry, top would be incremented, left will be also incremented, and right will be also shifted, and bottom would be also shifted. So is this what it was? Yeah, looks like that. Yep, looks like that. So let's give it a try, and hopefully we can solve this. But I was not able to and my camera will die in some time, so I just reset it. Okay, so let's give it a shot. First of all, in a matrix question, we will try to get um, row matrix dot length, that will give us row, and let column, let call len, and let's say row len equals to matrix dot matrix of 0 dot length. Okay, and once we are done with this, we need to figure out okay, what will be our boundaries. Let top is equal to 0, left is equal to 0, right is equal to call len minus 1, and bottom is equal to row minus 1. So we got our boundaries, and we want our result to be an empty array, and we want to say return result. Okay, so we'll be running this entire loop, while result dot length is less than row len less than equal to oh it is less than row len into call len. Am I considering all the choices? Yeah, okay. I thought I might be missing a index. Okay, so we've done this, and then okay, so first of all we'll traverse the topmost layer, then for let I is equal to 0, no, we have to traverse the column, right? So column would be starting at left, whatever the left is pointing at, left, call is less than equal to right, and call plus plus. So result dot push, we got a push call result dot push matrix of top and call. So column will be traversing the column, and then we have to check for let row, we have to traverse the row, right, which will be starting from top plus 1, because we have already traversed the top, so we don't want to traverse the top element again, and it should be row should be less than equal to bottom, right, and then row plus plus. So result dot push matrix of, we have row and top, sorry, a row is what's going to change, then we have right, so we will be traversing the right column, so that's why right. once we are done with this, we need to make sure that if left and right, so I see now why they are doing this, because we need this check if it, just in case, if here once we come down to what, oops, once we come down to um, this guy, the 4 5, then at this stage um, we shouldn't run again the same loop for this row when for top and bottom. So just to avoid that confusion, once top has traversed that, we don't want bottom to again traverse that particular row. And similarly it goes for the left and right. So there might come a point where both might be pointing to the same row or column. So top is not equal to bottom, and what we do is result dot, what am I doing, we need to first run for let. So again we have to find out a column, right? We need to go from left to right, so this would be right -1, and column is greater than left. We have to do this and call plus plus. So it shouldn't be equal to left, or it should be, yeah, it should be equal to left. So we'll do it until it is equal to left, then yeah. So result dot push matrix of bottom, yes, we are starting from bottom, and column. So the last one here, left and right shouldn't be equal to each other. Need to make sure that it's not happening. And then for let column right, so yeah, we need to check the row, and row should be starting from left plus, oh sorry, row should be starting from bottom +1, yeah, and row should be greater than equal to top it shouldn't be greater than equal to top, it should be, we shouldn't revisit that left again, right? So in that case it should be, yeah, then row plus plus, row minus minus, sorry, minus minus, and here also I did it wrong, row minus minus, column minus minus, and then result dot push matrix of row and, sorry, what am I doing here, row should be this guy and column should be the left, once we pushed everything, then we can just do top plus plus, left plus plus, right minus minus, and bottom minus minus, right? So that should do it. I'm not sure if I've followed the boundaries pretty well. Okay, that is right. Yeah, this is also right. This is cool. This is cool. Yeah, everything looks good. Plus 1, right minus 1. Okay, yeah. Oh, down bottom minus 1 here. It should be, yeah. Cool. Okay, so row len, right? We should have given here row len instead of this. Let's submit this. Okay, it was accepted and accepted. Okay, cool. This is pretty interesting question, and yeah, the time complexity is big O of m into n, because um, that even if we are anyways running these for loops for m into n for these number of cells, and the time complexity is of 1, yeah, because solution time complexity is not counted. Okay guys, that's it for this one. I know I struggled, but yeah, let's try to solve the next question with the knowledge of this, and hopefully not struggle in the next question.